So it feels like AI is hitting a bit of a wall, right? To get smarter, to get better at reasoning, it needs a new way to learn. Welcome to The Explainer. Today, we're going to break down a really cool breakthrough called PretrainZero, a technique that, believe it or not, teaches AI to learn a bit more like we do. All right, here's what we're going to cover. We'll kick things off with this big problem called the data wall that's holding AI back. Then we'll look at an early idea that totally flopped, see how human learning gave researchers a new inspiration, and then dive into how PretrainZero's clever little game is completely changing the future of AI. Let's get into it.
Okay, first things first. To really get what's going on, we need to understand the major bottleneck that's slowing down AI development right now.
You know, AI models are already incredible at so many things. They can write, they can code, they can create amazing art. But the next big leap, the real frontier, isn't just about doing more of that, it's about thinking better. It's about improving how an AI can actually reason through really complex problems.
And this is where we run into a huge problem, what researchers are calling the data wall. See, to teach an AI to reason better, you have to feed it these perfect, hand-checked, human-verified examples. It's like creating the perfect textbook for it. The issue? Creating that perfect textbook is incredibly slow, it's super expensive, and it has become the single biggest thing holding AI back.
Okay, so what was the first idea to get around this? Well, let's look at what researchers tried first and see exactly why it kind of flopped.
The first thought was actually pretty logical. You've got these two main ways to train AI. There's pre-training, where the AI just soaks up general knowledge from the whole internet, Wikipedia, books, the works. Then there's post-training, where it's fine-tuned with that super expensive, high-quality data. So the question was, why not just use those powerful teaching methods from post-training on all that free internet data from the get-go?
Yeah, that did not work at all. The thing is, raw internet data is just messy. It's full of junk and noise. Trying to learn complex reasoning from that is like trying to study for a final exam using a textbook where half the pages are just random gibberish. The AI just gets confused and its learning process completely breaks down. And this chart, wow, it shows you exactly what happened. When researchers tried to get the AI to focus on the hard examples in that messy data, the stuff it found confusing, the learning didn't just slow down, it completely collapsed. You can literally see its performance just fall right off a cliff. It was crystal clear that this simple brute force method was a dead end.
So if that didn't work, where do you go from there? Well, the creators of PretrainZero looked to a really familiar source for inspiration: us.
Think about it. When a really good student studies, they don't just passively reread the entire textbook cover to cover. No way! They actively hunt for the things they don't get. They find their own weak spots, and then they create little challenges for themselves to specifically work on and strengthen those areas. We call this active learning.
And that is the core idea behind PretrainZero. It was built to mimic this exact process by basically creating a kind of internal study buddy for the AI.
So inside this one AI, you've got two parts basically playing a game with each other. On one side, you have the mask generator. Think of it as the study buddy. Its only job is to look at some text and come up with a really tricky fill-in-the-blank question. And on the other side, you have the mask predictor. That's the student who has to try and solve the puzzle.
Now here is the really clever part. It's a competitive game. The study buddy only gets a reward when the student gets the answer wrong. This forces it to get better and better at finding the student's weaknesses and creating tougher questions. The student, meanwhile, gets rewarded for getting it right. It's this constant back and forth, this adversarial tug of war that forces the entire AI to get smarter.
So, for instance, the generator might grab this sentence from Wikipedia about a racehorse. Instead of masking a random word, it identifies a key term that requires real context to figure out, and it hides the word stakes. It's not a random guess. It's a very targeted challenge.
And in response, the predictor doesn't just make a wild guess. This is the cool part. It actually writes out its reasoning step by step in what's called a chain of thought. It looks at the context, it sees the other horse races mentioned, and it reasons its way to the conclusion that the missing word has to be stakes. This is that active learning process in action.
Okay, so the idea is cool, but does this whole adversarial study session actually, work? Well, the results are pretty dramatic.
And the results really do speak for themselves. On general reasoning tests, you can see the PretrainZero model scores way higher than the original base model, and it just crushes that failed random approach we talked about earlier. This active, self-teaching thing, it's clearly working.
But check this out. The place where it really shined was in mathematical reasoning. The jump here was even bigger. Math is such a pure test of logic, and these results show a massive leap in the AI's ability to handle complex problems with numbers, something AIs have historically struggled with.
I mean, a 10.6 jump on average math scores. That isn't just a small tweak. That is a fundamental upgrade to the model's core abilities. And it was all done just by using this new technique on freely available data like Wikipedia.
So what's the bottom line here? PretrainZero makes the AI's foundation much smarter right from the very beginning, before any of that expensive human fine-tuning even starts. It's like having a student who shows up on the first day of class already understanding all the core concepts. All right, let's tie this all together. What should you really take away from all this? And why does this new way of learning matter so much for what's next?
At its core, PretrainZero offers us a path to much more powerful and efficient AI. It helps us break through that data wall by teaching the AI how to teach itself. It turns the model from just a passive listener into an active participant in its own education, which means we can create stronger AIs faster and without having to rely on those expensive, special datasets.
And that leaves us with a really fascinating question for the future. If AI can become a more active learner, constantly finding its own weaknesses and improving itself, what new capabilities is that going to unlock? What's the next great barrier that's going to fall? Thanks for watching.